Now, why you'd ever do that? Most people do this in their book. When you start a math problem, I used to do this when I was in school. I don't know why. We'll talk about it first. Okay, we'll keep going. I'll post a list of our different property names, and then Thursday we'll continue. Now remember, I'm not here Thursday. You'll have a sub. Just take it easy on them. Now remember, we do have page 130 due, so make sure you are working on that. Sub will go through a couple notes. You'll maybe have some time for a study hall on Thursday. Friday we'll pick this up again.
Thursday is a Monday.
Yeah,
Friday. Friday.
Oh, yeah.
That's a crazy week. Where's food? You know some really fruit Wednesday?
But literally,
Who? Connor, yeah.
No, Connor's won't be there.
Why not? Does that work?
Wait, are we still having it?
guys, we have another one of those quizzes today. If we don't do good, he's adding half, like, an additional problems onto it.
Oh, boy.
He tell us this morning we're supposed to warn our classes. We don't do it out today. We get twice as much homework.
His lesson, last one.
He's giving us like one of those quizzes again. If we don't do good on it, then we're getting twice as much homework so we can learn it for our test. And I say he's dead serious because yesterday they were ridiculous. So if we don't up it today, then we get double homework.
So it doesn't count as a grade?
No, it just counts for how much homework we do.
I was thinking we might have a pop quiz of...
Wait, Connie. Jackson, take on our lesson.
I don't know if all Zach's supposed to tell us that, but he told me not to.
He was lightly strumming the guitar. And
slapping the bass?
No. And then I had the other guitar, I was strumming along with him. And then it kind of turned into a jam session more than a lesson. But I did learn a lot. At the end, there was then we did speak on this. Go around the room, everyone said something. Go around the room, everyone spoke. It really did. Your lesson that you were late for, fire, about 40 minutes late.
Hey, you know what? We were at Pizza Ranch.
We're doing it wrong.
Yeah, you gotta make food or an extra hour.
Okay.
Are you kidding me?
This is why people want to come here.
I can stand it. I got jeans.
I got a supply buyer for what?
Big game. Yes. What are you books? How are you? They'll be here. Take off. Literally, Jackie said
28 pairs.
last period. What if we had
$20
this
top.
one's legit? Great.
Wait, it's graded?
You didn't even tell us.
Oh,
You've been more than prepared. So, all right.
What the?
Hey, you have 5 minutes. I'll take a look. Okay, you have 5 minutes.
Alright. What's it?
If you need a light, I'm sorry. I'll turn it back on. But if you need to see the graph in your paper is a little blurry. I know. This one looks a lot better. This is what it originally was, and then when it prints, it doesn't look good. So.
We just read the answer for that.
Yeah, just make sure it's easy to read.
Yesterday's score paper is that?
I'll give you your papers back from yesterday.
I remember why.
Okay. another sheet of paper. You need to mark down your previous score from yesterday. If you have not marked down your previous score. Okay, I'm going to take those back here in a minute. Okay, here's what I want. Take your piece of paper, hand to the person in front of you now. In front. So if you're in the front row, you have to pass through the back row. So pass to the person in the front. Okay, all right. So remember, be brutally honest with them. Don't give them cheap free points. This isn't helping them. Okay, you want to be brutally honest. Like if they don't get the right answer, count it wrong. Okay, all right. So now, let's pop up the picture up on the board so you can see the answers here. All right, so these answers I just did here 2 seconds ago. All right, so I know the graph's a little blurry because it's the same picture you guys are looking at. All right, so domain. Domain are the x numbers. Negative infinity, because there's an arrow, negative infinity all the way up to the number 6. Bracket at 6. The reason there's a bracket, it doesn't go past 6. There's a dot there. There's a dot there. Okay?
I thought that was an arrow.
Nope, that is a dot. There's a dot there. All right. The range. Range is going from negative infinity, because there's an arrow over here. Jeez, that is negative infinity up to the number 1 for the y numbers. So, because this arrow keeps going down, so the range is negative infinity and up. All right? So that's your range. Zeros. Where does this thing hit the x-axis? Well, it hits there at -3, +3. Now, if you give me the coordinates, that's fine. Maybe you said -3, 0, or 3, 0. That's fine. I just need the numbers. Where did it hit? Where is f of 0 at? F of 0. So if you plug in 0 on the x-axis, it gives me the answer 1 out of that thing. That's what we're doing. That's evaluating the function at the number 0. Right? All right. Interval, where this thing is increasing. I had some really good questions on this. Okay? Interval where there's increasing. That means where your slope is positive. Right? So that's going from negative infinity up to the number -2, and we're not going to include -2. The reason why, it's being shared between the constant graph and the increasing graph. So we don't share it. I had a couple people ask that. That's a really good question. Okay, I know it's not decreasing. Don't get me wrong. It's not going down there. But it is shared between the constant. Okay? All right. Where is this graph decreasing? From 2 to 6. And 2 is not shared, but 6 has a bracket because of the dot. There's no arrow there. Okay? And remember, we're using x numbers when you do increasing and decreasing. Don't use the y numbers. Some people get really confused with that. That's just domain. This is all this stuff is. Values for this thing is greater than 0, where the graph is above 0 on the x-axis, right? So above 0, I should say, like above 0 for y numbers. This thing is above 0 from -3 up to 3 and not including this. So it's just above that. So any numbers in here. So I don't know if you use like an interval notation from -3 up to 3 with the parentheses. You're not including those because those are where it equals 0. Or if you just went like, you put the x on your paper and you went like less than 3, greater than -3. I don't know how you put that. So there's a couple different ways you can write that. Values for which f of x is equal to -2. There's 2 different spots where this function hits -2. It hits -2 right here, which is at -5. It hits -2 over here at +5. This notation is where does it hit the y-axis? This is the y number. This is the x number they're looking for. That would spit that answer out. Okay? Is f of 4. So if I plug 4 into this function, is it positive or negative? Well, it's negative. It's -1 in fact. And is this graph even, odd, or neither? It is neither. It is the trickiest one you can ever see. Yeah. If it was an arrow, that would be an even graph. It would be even if there was an arrow, but there was a dot. So it is neither, because the left and right side are not the same graph. Because it stops at one point, the other side doesn't stop. So it's neither. So that's kind of a tricky question. And then the last question, I don't know if you've seen number 11 there. 11 is is f of 2 a relative max f of 2 is 1. That is technically a maximum. So it is, yes, it is a maximum. It's actually called the absolute maximum. Does that make sense? So if you put no, it's absolute, I'd probably accept that. But it's yes, it is a maximum. That's relatives are just, is it the highest point in the graph? Yes, it is one of the highest points. It just happens to be the absolute highest. There's nothing above it. Does that make sense? Yeah, if you put no because you thought it meant like absolute, I'd probably accept that.
I put yes slash no and then I put absolute.
Yeah, see, I'd accept that.
Okay. So I wasn't sure what you were looking for.
Relative maximums are any time the graph does like a little peak. That's fine. It's doing a peak, so it is technically it is a maximum. It just in this case it is the absolute maximum.
So does it have to be included in the y?
Yeah, I got 5 out of 11
What?
this time.
Does it have to be included in the y?
F of 2, so 2 is right there.
Oh,
F of
I would have gotten a lot more, so I realized the graph was going
All
up.
right, hey, hand it back. Put your score at the top, and then I'm going to collect both of these back together. Okay, so I'm going to collect both those. So whatever your score is, so maybe you got 10, maybe you got 3. I'm hoping that you at least stayed above passing if you were, or you at least improved. Okay, so hopefully you're still above passing. It could be simple
When I
error.
was looking at that,
That was an error.
I looked up there and I had to go back and change it. That's how we got it.
I got 5 out of
I would have known I was a dog instead of an arrow.
Right? I would have gotten 100%.
Hey, let's Tyler's. Yep. Kind of. Alright. 3 better than I got this young.
So you have 3 out of 11?
I didn't say that.
Yeah, Jack, if that was
Now, hey.
if that was
Now, hey.
if that was an arrow, I would have gotten it.
Oh, yeah. Yeah, Theo, you have the right numbers.
Okay.
Probably would.
Now, hey, thumbs up, thumbs down, anything. If you want to be discreet, that's fine. Did you stay positive or did you improve? Give me a thumbs up. Did you stay positive or improve? Are you passing?
No, I didn't.
Well, a lot more thumbs up than yesterday. Because yesterday, like the scores that like overall, I think the average was like 4 out of this class out of 11. Okay, there are some people, and the reason why some people pulled it up. There's a couple like huge scores that that help that average. Okay, so some people, if you didn't do as well, like you went down. Hopefully, it wasn't by a lot. It was maybe 1 or 2 points, and it was probably the stupid arrow thing, wasn't it? Yeah, that's fine. Those are things that, like, if the graph was a little bit prettier, you would probably notice that. Okay, so, but here's the thing: did we get better from yesterday to today? Yeah, so that's a good thing. So that definitely helps out. Okay, is there any questions, comments, concerns on this thing?
Is it graded?
No.
Okay. I'll give number
7. Okay, values for where f of x is greater than 0. Where is this picture above 0 on the y-axis? Because this is the function, these are the y answers. So where are the y numbers above 0? It's in this range and up, right? It's up this way. This is where the graph's above 0. So, because I'm looking at that, so it's from -3 up to 3. And to be above 0, you can't include these numbers because those would be equal 0. So this is the part I know some people get really confused about it. They're like, well, isn't it from like 0 and up? They're thinking like x numbers. I want y numbers. That's what I want. Okay.
So I had the right idea, but I didn't do the notation. I just listed like -2, -1, 0, 1.
Oh, yeah. You have to include them all because it is a solid line. If there was individual dots, you would have been fine. But since it's a solid line, you have to include all numbers, including decimals.
Okay.
That's why that's all.
I get number 3 and number 4 confused.
Zeros are intercepts. It's just evaluating. This is just like plug in 0 into your function. What would it spit out for a y answer? That's what this one is.
Number 4 is where it hits.
Where it hits the
Y
graph.
axis.
Yeah, where it hits the graph. The y number.
And the other one's on the x axis.
Yeah, what x numbers? That's zeros. That's they say x numbers. That's are just domains. Increasing, decreasing, constant. It's just domains, like what you did up here. So it's just like what's the lowest number and going up. So like when you're increasing, is this graph going from left to right? Is it going up?
Well,
Even though there's an arrow, it's going up that direction as you go left to right.
I had it flipped around because I saw the arrow going down, so my immediate thought was
Now,
to go that
decreasing
way.
is when you go left or right, is it going down, left, or right?
Okay.
So it's based on slope. Is slope positive, 0, or is it negative slope?
Like, on the increase one, also 7 can include negative
You
2.
don't include negative 2. That's why I use the parenthesis. That's not including.
See, I thought you just went down number 7.
No. So you put negative 2, but you just use the parentheses, not including. That's the idea. If I put a bracket, then you use that. Not a lot, because it's shared between the constant and the going up. Yeah. Other questions? These are good.
How would you write out number 7 at the answer? Like if you were to list off all those things, you said that.
Oh, there's a different way to write it.
Yeah.
I would write it like this. Like if you want to go like, where's this graph above 0 or 7? This is how I would write it. You're like less than 3 but greater than 3 on the x-axis. That's the other way to write it, other than doing like the interval notation idea. I prefer interval notation. It's cleaner. It's easier to look at. Problem is, some people look at it and they think it's coordinates. It's not. It's like there's an actual interval there. Okay, those are good things. So obviously, like for next week, next Thursday, when we have a test, you know, are we going to be more than prepared? Well, obviously we're getting better, so we have another week to get better at that. Okay, but this is like everything up to this point, everything from chapter 1 so far. Now, let's move on. We got to talk about piecewise functions today, because I want to do one where we have a dot, one where we have a curve, and one where we have a line today. So that's kind of what I want to do. And then once we're through that, then we've got to talk about that differential quotient, so you know how to do one if you have a tough problem today. So that's kind of what we're looking at. So you need your notes out for right now.
Bailey Freed, please come to the office. Bailey Freed.
All right, so we're going to do a piecewise function. I said yesterday that when we talked about this piecewise, I want to do something with maybe 3 or 4 pieces. Piecewise function. And I want to do something where there's like a dot, there's some open circles, some closed circles, that type of thing. So we can see the difference in graphing. Okay? All right, so here's my function today. We're gonna try to practice this. Hopefully this makes sense. We'll try to color code as we go. So I'll kind of show you those. So the first one we're going to do like, we'll do an x plus 2 for any x that's less than or equal to -3. We'll have, we'll go x squared minus 2 for anything that, for any x that is, less than 0 but greater than -3. And we'll have this one, 2x plus 1 for any x that is equal to 5. And negative 1 for x and x is okay, so on this piecewise function, how many graphs am I going to have? How many pictures? 4 pictures. No, they technically, hopefully they're not connected to each other. Hopefully they disconnect. But you can kind of see how this is going to work. There's going to be a couple places where there's just a small band. This graph does have linear functions. Actually, it has 2 linear functions. It has a curve of some type, and it also has a solid dot on one point, like a single point. Can anyone figure out, like when you look at that function, which one is going to be just a dot? Yeah, the x equals 5 part. So that's the 2x plus 1, that function. That'll just be a dot on the graph. The reason why, when you look at the domain, you're only plugging in one number. That's it. You only have one digit. When you plug in one digit, one dot. That's all you can use. That's a single dot. So we'll have kind of everything here. So the first one we're going to do with this in green, so what kind of color code as we go. We're going to do this top one first. This is my function. These are the x numbers I'm allowed to use. Now, when you look at this domain, am I going to have a solid dot or an open circle? Solid dot. It's equal to. So you can use the actual number. It won't be open circles for the first one. And what number do I always plug in? I'm going to plug that -3. The number they tell you, you got to plug that one in first, no matter what. You got to plug that one in. Okay? All right. So we're going to plug in a -3 into this thing and see what the answer is. And I'll put a dot there. So if I plug in -3, what's -3 plus 2? -1. So there's where the dot is. It's at. We plugged in the -3 first and spit out the answer of -1, right? So -3, -1. That's a solid dot there. Okay? Because I'm allowed to use it. Now, let's keep going. Let's plug in another number. So what's another number that's less than -3? -4? We'll plug in that number. So let's plug in -4 in now. Let's see what the answer comes out. So I'm plugging in a -4 into this function. I get -4 plus 2, which is -2. So that's that coordinate. So -4, -2. So where is this graph going? Down, going that way. And the reason I know it's going that way, it's a line. There's no power line. So I know it's a solid line, so I can just draw that right away. Notice it has an arrow. I'm using all numbers less than -3. So I can go forever in a straight line. So when you have lines, just draw 2 dots, draw a line. And you got to go the right direction. Okay, questions on the first one? How I did that? I'm plugging in numbers from the domain into this thing and just graphing. So if you want to get going, you can draw it, but you have to draw a line. Okay, the second one. This is a curve, and we're limited. We're limited between -3, which will be an open circle, so I'm not allowed to use it, and up to 0, and that would be an open circle. But I have to plug the numbers in here to see kind of what we're getting. So let's try the first one. I'm going to plug in the -3, and that'll be an open circle there, and I'll try to color code as we go. So we're going to start with this number, because that's my lowest number I can plug in, right? And we're going to plug it in here. So -3 squared minus 2. So I'm going to have, what is that? That's going to be 9 minus 2, which you're right, was 7. So plugging in the -3, it gave me the answer of 7 out of that thing. So -3, it'll be at 7. 1, 2, 3, 4, 5, 6, 7, and that'll be an open circle there. Agreed? Okay, now this is a curve, so I need to plot a couple points until I get to 0. So let's try -2, we'll try -1, and we'll also try 0. The rest of these, in the middle, these will be solid dots, but the outside ones will be open circles. We're not allowed to use these 2 numbers, just the ones in between we are. So, let's plug in like -2. Let's see where this thing's going. So if I plug in -2 in here, plug in -2 in, let's see what happens here. So I'll plug in -2. -2 squared is 4. What's 4 minus 2? Yeah, so the answer would be 2 there, right? So I plugged in -2, gave me the answer of 2. The 2 gave me the answer of 2. That's a solid dot. I was allowed to use that. Let's plug in -1 now. I get -1 squared is 1. What's 1 minus 2? -1. So when I plugged in the -1, it spit out the answer of -1. So that's this dot. And the last one we're going to plug in is 0. What will that answer be? 0, -2. So I plug in 0, it'll be -2, and that's got to be an open circle. The reason why, I was not allowed to use 0. So it looks like it's this. It's an actual curve. Just so you know, x squared graphs look like a bowl. That's kind of what they look like. But we're only going for a certain part of that. If we kept going, it'd probably bow back. But we don't have it. We need to start and stop. Does that make sense for that graph? Okay. Next graph, we just have that dot here. So we're going to plug in the 5 now. I'm doing this in black so you can see this. So we're going to plug in 5 into this thing. 2 times 5 plus 1. 11. So 5 comma 11, right? 1, 2, 3, 4, 5, comma 11, and that's just a solid dot. We'll use that. It's just a single point on a graph. And the next graph, we have to, because that's it. I only had one number to plug in. That's it. That was a dot. Let's go to this last graph. Everything greater than 6. So what number am I going to plug in this thing first? 6. So let's plug that in. So I'm going to plug in 6, and even though it'll be an open circle there, plug in 6, I'm going to take it times a -3. So take 6 divided by 3 and put a negative sign on it. -2. So when I plug in 6, this is 5, right? That's 6. It gave me the answer of -2, and that was an open circle. Okay, let's try another number, because this is going to be a line, right? Let's try like the number 9. I like to use kind of nice numbers. So So let's try plugging in 9 now, because that's a number that's definitely greater than 6. Negative 9, or 9 divided by 3 is 3. Put a negative sign on it, so it's what, negative 3. So 9, negative 3. That's a solid dot. So why do we use that number? And then where's the back graphs going? So you have like a bunch of different graphs going on here. Now, why did I know the last one's a line? That's fun. There's no power. If there's a power, I'd worry about there's a curve there. There's no curve, so I can just plot 2 points. Plugging numbers that are easy. Always start with the first number that they tell you to plug in, and then plug in another number. Something that you know is going to work. Because I know divided by 3, I'm going to use like a number like 9 or 12 or something like that. But the rest of them are pretty straightforward. Especially that curve. That curve's kind of the tough one. There's 2 end caps that open circles, and then the 5 is a point. That one's pretty straightforward. Alright, questions, comments, concerns. Does that make more sense for piecewise functions? Okay. On your homework, I'm just going to give you a few, and then you just graph them, just like this. And they're not going to have 4 pieces. They're going to have 2 pieces. You can see there's 2 things on each graph. Kind of doing their own thing. Alright, differential quotient. This is the last example of the day. Differential quotient, I'll tell you what the formula is, and then I'll let you guys pick the equation for it, so we can like try one out. I'll let you kind of pick whatever you want.
Math section reads, Joe from Athletico is ready for any juniors or seniors that need to see him. If you are a junior or senior that needs to see Joe, please make your way down to the locker room area at this time.
Alright. So, that's your differential quotient. Agreed? Okay, so that's your formula. So, how that formula works, the top left corner of that fraction is f of x plus h. That's where we're gonna substitute x plus h into whatever your function is. That you guys will create that here in a minute. And then we're gonna subtract the original function, whatever you guys come up with. We'll subtract it off, and we'll divide everything by h, and we'll simplify that thing down. All this formula is gonna give you is slope. Now, if you pick something very complicated, it will give you a formula in the end. If you pick something very easy, like a linear equation, it'll just give you a number out. Linear equations have just slope. There's a constant number for slope. Okay, got something you want to use?
No, I was just going to ask a question.
Yes.
H is technically 0. How can you do
It eventually h is not 0. It's getting so small that it's almost approximating 0. Because if we want to know like when we can eliminate these constants, they get so small that it's just negligible. Yeah, it just kind of goes away. So. I know, like you don't want to divide by 0. So h is not 0. It's what happens when it approaches. So it's half or a quarter of h. So, yeah, good question. Alright, so let's make up a function. You guys can make up anything you want. Try to make up something like an actual function. So I can actually know. So, you can do it for a number, but it won't make any sense. So say it again. This function. Curved line, what is it? Curve, got x squared on it. So that means that when I do this differential quotient, when I simplify this, it'll give me just a formula in the end. Something that will help me find slope, because that thing's a curve, so slope changes. So it'll give me a formula in the end. If it was a linear graph, like let's say you guys left the x squared off, then it would just spit out what the slope is for this problem. Like what if this was a linear equation, 7x plus 4, what's the slope? So 7, that's what it would spit out. That's how you know. But since this is a curve, it's actually linear. So, okay, so here's how it works. We're going to take this formula right here, and we're going to use your function, the one that you guys created here, with that. So the first step, I need to take the x plus h and plug it in here. So that's x plus h squared plus 7x plus h plus 4, right? So that's your formula with x plus h plugged in it, right? And now what do I need to subtract? Yeah, the original function, the original thing that you guys created. X squared plus 7x plus 4. I'm going to subtract the original thing off. And what goes on the bottom? H. Okay, now does that make sense now? Whatever formula you guys have, you have to plug the x plus h in it.
I was doing the opposite. I was plugging the formula into the x plus h. Well, that's what I was doing.
Hey!
Okay, so now that we have that, now that we have my function with x plus h plugged in, now what we're going to do is we're gonna simplify this top, and we're going to divide by h in the very last, and we'll just leave whatever that answer is. Okay, so let's kind of work through the top here. This part right here, I have to FOIL it up. There's literally like 2 parentheses, right? X plus h times x plus h. So I'll FOIL that out here in a minute. This part, how do I deal with this? Exactly, you distribute the 7. So plus 7x plus 7h, no parentheses anymore, plus the 4. Now, back here, yeah, you got to distribute the negative sign. Good, distribute the negative sign to everything back, and the h is on top. Alright, questions, comments, concerns on the start. Remember, don't forget to distribute the negative sign to the back. That's just the thing you're subtracting original items. Okay, now I need to FOIL that first thing out. First, outer, inner, last. So first, outer, inner, last, this should be x squared plus 2xh's plus h squared. Because it'll be x squared, xh plus hx, which is the same thing as those, and then h. Stop. Keep going across, 7x, 7h, plus 4, minus x squared, minus 7x, minus 4. All over an h. Alright, and now the last step, here's how you know you did it right. If things that don't have h's go away, so you know you did it right, because I'm just going to be combining things on the top. So like x squares, those are gone. The 4's are gone. The 7x's are gone. So we did everything right. Things that have h's are left over. So what I'm left with here is a 2xh plus h squared plus 7h. And we're going to divide everything by h. And your final answer is divide everything by h. This is that log division that you divide everything by h. One at each item.
So why doesn't it go each split?
Oh, you can rearrange any order you want. I don't care about the order this is written in. So if you want to put the h squared in the front, that's fine.
Okay.
So yeah, it made no difference how you wrote that down. So let's divide everything by h. So what do I get in the front? 2x. Okay, plus the h plus the 7. That's your front answer. That's all I want. You don't need to like plug in numbers. I just want to know like what does this thing simplify into? That's it. You're done. You can do the next part. That's the differential quotient. That formula that you're looking at will approximate what slope is for your function. It will do it every single time. Okay, question? Yeah, you don't use h because h's are when they get really, really small, and then you start plugging in like values for x's. You can approximate what slope is at any moment. Yeah. That's something you get like they start doing decimal approximation. Okay, it's good. Okay, any questions, comments, concerns on anything that I have on the board? I'm gonna leave those up there. Okay, here's your homework today. Now, since you guys definitely improved on that quiz, I'm gonna give you a incredibly short assignment. So if you hear the other classes have a longer assignment because they didn't improve.
I told our class that before we
So,
started.
alright, here's your homework. And it is most definitely shorter. 33, 34, 6.
Is there still some problems in there about the stuff that we went over?
Yes.
Okay, yeah.
There's just 1 or 2. Alright. I'm going to make this thing due Friday.
I don't even want to know what the long version is.
It was about twice as long. Not long. The other ones that I had, there was a bunch of problems in front of 33. It was nearly 1 through 32.
We get to do all that.
So the class that doesn't improve on their quiz score, they didn't pay attention.
Has anyone done that yet?
Oh, you guys are the first class
First
today.
class.
So if you checked, in fact, if you would have checked online yesterday, like on the website, before walking to class, I actually had the assignment printed because I thought we were going to get it yesterday. But since the scores didn't go as well, we didn't get the assignment. And so, but yeah, so that assignment would have been incredibly long. It's due Friday. Now, just to warn you, we have parent-teacher conferences tonight. No classes tomorrow. Teachers are, I think, they have professional development all day. I am not here Thursday. You have a sub. Miss Stephens will be here. She's going to introduce the next topic. So she's not the sub. She's actually filling in for the sub. So the sub doesn't have to know anything. So she'll be in here. She's going to introduce linear equations, stuff like this. But we need to talk about the different forms, how to use them, what we're going to use them for. Okay, so it'll be a brief introduction. She'll probably have you use some stuff on Kahoot and other things to get kind of some practice. So she's pretty creative on that. And then Friday, we'll kind of wrap it up. Okay, now, just to warn you, we do have a test in here next Thursday. You'll get the practice test this Thursday. Have a week in advance. Miss Stephens pointed it out. So, and that'll get you kind of mentally prepared for what's going to be on there. There's story problems. There's things that you need to be able to handle. Okay, but yeah, about 2 more minutes here. Now, hey, don't spoil what we did here today, especially this quiz. I want those other classes not having an idea what you guys did, so don't tell them.
You should tell Maddie that, because I told my class.
I think she's lost class.
Do you have those little erasers anymore that you throw in this thing?
No, the class is in order. We got this from Arn somewhere. So,
Freshman year, we play that game.
Nope. I have that next.
you got my walls all dirty.
Beat you every time.
I'm probably gonna get some super low.
7.
My name's
So no, my coworker. I'm not
See that
What
word?
kind of was it? You already distracted.
Where did you see that? My name's
Like 5.
Here's like 1 minute.
5 after.
highlighter pen. Your brother can. Where's the eraser? Really?
Okay, parents teacher conference tonight. If your parents want to come, I'm only here from 4 to about 5:30-ish. I'll be leaving here a little bit earlier than that, but parents like to come, I'll be here. Thursday, I'll be here the entire time.
What color are they? Well, this year, he showed me the design, like, earlier this year. And they're like black. If you still have no idea, it was like, so there was like, he showed me 2 different ones, but like, one was like with the font base.
Oh, that is a good graph. Seymour, we need something like that quality on the paper.
Maybe. I'm color black. I don't like color gray.
I always do.
1 minute, and then the next minute, he yells at you. So I was like, what?
I think he actually worked.
Just like we're trying to say,
Is that yours?
good tapping. Do you want to hear us?
Block somebody else?
But like last year,
That's what I did. I was like, oh,
she's still like that.
So you.
broken.
What?
I got 90.
Yeah, 90 and what?
Are you kidding?
Not at all.
I got a 60.
I hate
90?
I've seen you, but
You'll get that.
I got a 60.
Me and Leah both got 90. Both got 77.
oh, better.
That makes me mad.